In this video, I will explain how to derive Hicksian demand functions, also sometimes called compensated demand functions. So let's jump into an example that says, consider the utility function u is equal to x to the 1/2 times y to the 1/2. Find the Hicksian demand functions for goods x and y. Now, Hicksian demand functions, these are demand functions that tell us the quantities of goods x and y that we can consume that will minimize our expenditure while still achieving a specific level of utility. So let's write that down. So our goal is to minimize our expenditure E, and our expenditure will be equal to the price of x times the quantity of x plus the price of y times the quantity of y, subject to, so let's write ST, subject to the constraint that u, our utility level, is going to be equal to x to the 1/2 times y to the 1/2. So the way we're going to solve this problem is we'll start by writing our Lagrangian. Let's abbreviate that as L. And that's going to be equal to, we'll have the right-hand side of this expenditure equation. So we'll say P of x times x plus P of y times y. And to that we will add lambda times u minus the right-hand side of our utility function. So x to the 1/2 times y to the 1/2. So here's our Lagrangian. Let's go ahead and simplify it a little bit by distributing this lambda into the parentheses. So we'll have the price of x times x plus the price of y times y plus lambda times u minus lambda x to the 1/2 y to the 1/2. So we will start by first taking the derivative of the Lagrangian with respect to x. So the derivative of this equation with respect to x. So that's going to be the price of x, so the derivative of this term is the price of x, plus the other term that has x in it is this term right here. So the derivative of that term with respect to x is minus 1/2 times lambda x to the negative 1/2 times y to the 1/2. And what we're going to do with this is we're going to set it equal to 0, and we're going to solve for the price of x. So it's pretty easy to see that the price of x is going to be equal to 1/2 lambda times x to the negative 1/2 times y to the 1/2. Then we're going to repeat that process and find the derivative of the Lagrangian with respect to y. So that will be, remember we're taking the derivative of this with respect to y. So we'll get the price of y minus 1/2 times lambda x to the 1/2 times y to the negative 1/2. And we'll also set that equal to 0 and solve for the price of y. So we can see that the price of y is going to be equal to, we're just going to move this whole quantity to the right-hand side of the equation. So we have 1/2 times lambda, x to the 1/2 times y to the negative 1/2. And then lastly, we're going to take the derivative of the Lagrangian with respect to lambda. So the derivative of this equation with respect to lambda, that would be u minus x to the 1/2 times y to the 1/2. And we'll set that equal to 0 and solve for u. So we can see that u is equal to x to the 1/2 times y to the 1/2. The next step is we're going to focus on these first two equations, and we're going to try to solve for x and y. So I'm going to clear a little bit of space here. Okay, so here are the two equations that we said we have where we want to solve for x and y. The trick we're going to use is we're going to take the price of x divided by the price of y. Because when we do this, we're going to be able to cancel out these lambdas. So we'll have 1/2 times lambda times x to the negative 1/2 times y to the 1/2 divided by, we'll have 1/2 times lambda times x to the 1/2 times y to the negative 1/2. So we can see that these 1/2 lambdas will cancel out, and we can move this x to the negative 1/2 to the denominator to make it positive, and similarly we can take this y to the negative 1/2 and move it to the numerator to make it a positive exponent as well. So when we do that, we'll end up with y to the 1/2 times y to the 1/2 in the numerator, which is just y to the first, or just y. And in the denominator, we'll have x to the 1/2 times x to the 1/2, which is x to the first, or just x. So what we find is that the price of x divided by the price of y is equal to y over x. So now it becomes very easy to solve for x and y. So if we cross multiply and set these equal to each other, we'll find that x times the price of x is equal to y times the price of y. So we can see that x will be equal to y times the price of y divided by the price of x. And we can see that y will be equal to x times the price of x divided by the price of y. Now, the very last step to find the Hicksian demand functions is we're going to take these quantities for x and y, and we're going to plug them into the original utility function. So let's clear a little bit of space here. So let's start by plugging in y into our utility function, and we'll be able to solve for the Hicksian demand function for good x. So we get u is equal to x to the 1/2 times, for y, we're plugging in price of x times x divided by the price of y, and that's all raised to the 1/2 power. So if we simplify a little bit, we'll get x to the 1/2 times, we're going to take all of these individual elements and raise them to the 1/2 power. So we end up with the price of x to the 1/2 times x to the 1/2 divided by the price of y to the 1/2. So if we combine these two terms, we'll just get x to the first power. So we'll find that u is equal to x times the price of x to the 1/2 divided by the price of y to the 1/2. So remember, we're solving for x. So if we multiply both sides by the reciprocal of this quantity, that will be equal to x. So we'll find that x is equal to u times the price of y to the 1/2 divided by the price of x to the 1/2. So this is our Hicksian demand function for good x. And if we want, we can label this as x sub h to denote Hicksian. So this tells us the quantity of good x that will allow us to minimize our expenditure while still achieving a certain utility level u, given the price of y and the price of x. Now we can find the Hicksian demand function for good y in the exact same way. So we'll say u is equal to, this time we're going to plug in this quantity for x into the utility function. So we get the price of y times y divided by the price of x to the 1/2 times y to the 1/2. So when we distribute this 1/2 into all of these individual terms again, we're going to get price of y to the 1/2 times y to the 1/2, and we'll also multiply by this y to the 1/2 divided by the price of x. So again, these two will combine to make a y to the first power. So we'll have u is equal to the price of y to the 1/2 times y divided by the price of x to the 1/2. This should also be to the 1/2 right here. And again, to solve for y, we just need to multiply both sides by the reciprocal of this quantity right here. So we'll find that y is equal to u times the price of x to the 1/2 divided by the price of y to the 1/2. And again, we'll say this is y sub h. So this is our Hicksian demand function for good y. And this demand function is telling us the quantity of good y to consume to minimize our expenditure and still achieve a certain utility level given the price of good x and the price of good y. So that is the process that you can use to find Hicksian demand functions when you are given a utility function.